Okay, so we're live here with Infinite Layers, and today we're joined by the Nuffle team. So without further ado, please go ahead and introduce yourself, and then we'll dive right in.
Hey everybody, I'm Altan, one of the founders of Nuffle Labs and the CEO, but it's a meme because we're a very small team. Background is Frat and I used to be working at Near Protocol, and that's how we started building our DA layer, but also building on Eigenlayer as well. Nice to be here.
Hey everyone, my name is Frat. I'm also one of the co-founders of Nuffle Labs. Like Altan said, we're very small at this moment. I'm CTO, but it doesn't really mean anything right now. But yeah, we've been working together with Altan and the rest of the team in New Protocol. We're with the core contributors of New Protocol. Then we built New DA, which is our data vulnerability solution, and then built an NFFL on top of it, which is a fast finality layer built by the restakers on Eigenlayer.
Amazing. Yeah, so really happy to have you on. I've been keeping up with you all. I think you all have done a really good job in terms of a social media presence. You're very active. So I've learned a lot about Nuffle, but I don't know enough. So today I'm going to hopefully learn a lot more about it. So before we dive into like what Nuffle is, I'd love to learn a little bit more about the background of both of you. So how you kind of got into being a founder, but also maybe how you got into building in the blockchain world.
Yeah, I can start there. Mine was a bit of a luck. I mean, it was Evolabs reached out to me for like a job. So when they interviewed me first time, they were like, "This guy doesn't know anything about crypto." That was 2021. So I took that and I was like, I really want to learn about this thing, and started that summer basically going really deep. Developer by background, so I started building like Solidity contracts, going through hackathons. Did ETH Warsaw, and finally jumped onto Near just because I really loved Rust and wanted just kind of saw that as a sort of evolution. Did C++ work before, and saw that as an evolution of like the next phase sort of program language. And that's how I got in, and that's how I got the job at Near Protocol. Pretty much was like hacking through. I know Nether has been quite involved with hackathons, so just started like the other hackers really 3 years ago.
Cool, man. Mine's a bit interesting. So my background is computer science and distributed systems, and like I studied distributed systems, but I was not really aware of how blockchains work or anything. And then one night, I think it was like my master's degree first year, one of my friends sent a peer-to-peer cash system by Satoshi Nakamoto, and then I read it and I was like, shit, this is gonna be very big. It was already big, but I didn't know. And then I started digging in deep into it, and then I said like I have to basically bet all my life on this. And then weirdly by that time I was studying in Groningen, which is in the Netherlands, and IBM had an office there, and then they were doing blockchain research, and I just applied for internship. And then it's been more than 7 years I think that I've been in this space. It was first in the more corporate blockchain, which is now open. And after 4 years, I was like, this is great, but I also want to be more involved in building the open web. Then I was reached out by a New Protocol, and then I was in the protocol team. Since then, I've been building on Near.
Okay, so basically an OG, 7 years is quite a long time.
Yeah, right on, yeah.
So if someone was to ask what Nuffle was, what would be the elevator pitch? What would be like the 60-second answer?
So yeah, the current problem with L2s is that it fragments Ethereum, right? So you go to Arbitrum OP, and that takes sort of first like economic activity outside of the Ethereum ecosystem. So what Nuffle is, and we've saw an example of that happening quite last year, is that there's a lot of L2s launching, and in that world, there needs to be a layer that settles them quite fast. So Nuffle is pretty much like a fast finality layer AVS. Essentially, it's like a future contract that this L2 is going to finalize, and Eigenlayer operators basically agree that this sequence is going to finalize on Ethereum, and when it finalizes on Eigenlayer, others basically can use that to build multi-chain applications. So an example could be, for example, you're familiar with Lens. Now there's a Lens network that somebody, let's say, accrues their profile, and they can interact with, let's say, Mega ETH and do something else there.
And when you kind of came to the conclusion that you wanted to build this, what were what was the process like? So, I mean, ultimately, a lot of times people want to solve a problem that they've encountered themselves or that they've realized no one else is doing. Like, I think that's ultimately where a lot of successful products come from. You're running against, or you notice a problem and no one else is solving it in the way that you think needs to be solved. Was that the case here, or was this more of like, we're going to look and see what potential problems can be solved and try to bring the solution to market?
Both, I would say. So we know, like, we basically know, we believe in an asynchronous world from near blockchain. Near is a sharded blockchain. So we basically did, the shards can communicate with each other. That's actually kind of like rollups, because the rollups need to communicate asynchronously. The other thing is, like, Shuram last time, we were one of the first AVSs. So Shuram came in and said, like, Near is quite interesting. We want to build something with you guys. And the first thing that he probably comes to mind is like fast finality, which is Doomslug. So we kind of modeled that and came there. And actually, it's I think fast finality is one of the first ideas that Shuram put through in a blog post. So yeah, it's both like a bit luck, really. Like for us, we've been quite lucky with things, but yeah, from design perspective, but also kind of seeing what problems are there.
Yeah. So that's the NFL side, right? For the DA side, which is kind of like the base layer for NFL right now, we came to be is we already knew that Near blockchain was very, very cheap for storage, and then also it already inherently has data availability since it's an L1, and we saw this block space heating up, and then like we also had the same problem when I was also developing stuff on Ethereum. I was having a problem before 4844. Where I was like, oh, this is too expensive. I cannot basically send any transactions. Well, would it be so nice for some applications to have another DA layer that they can leverage? Maybe not comparable in terms of security, but much cheaper. That's how it came to be. So it was actually our own problem, also trying to solve the same problem, but that opened up a part of Near protocol to rest of the rollups.
Okay, to understand this better, let's dive in. I know you all had maybe brought a presentation that we can look into, and then from there we can kind of continue on with a little more Q&A.
Yeah, I can present. Give me a second. Slides.
Sure. You should be able to present, and then I can add your presentation to the screen.
Yeah, let me see. Slides. Share screen is good, yeah? I think that would work. Alt2Con. Give me a second. You guys see this?
Yes.
How about it? I have a white screen. Does that work for you guys?
Yeah, it's a little wide, but I think it's fine. What I'm going to do is remove our faces from here and make it the whole presentation for now.
Awesome. Yeah, I can't see you guys, so I'll whenever you guys let me know, I can start.
Yeah, you're good to go.
Okay, so we're Nuffle Labs. The name is quite funny. The name comes actually from NFFL, which is near fast finality there, and we're like, actually, this kind of reads like a Nuffle. It doesn't mean anything, but let's just call it a Nuffle. We're a bit, with our branding, we've been kind of a bit funny, like not too serious, because we don't take ourselves very seriously. So
wait,
what do we do?
Stand for then? Near fast finality layer.
No, it's actually
part of the.
There's two things, which like near fast finality layer was one, and then while we were like trying to find a name, one of our sort of friendly investors were like, oh, we should actually call it like near unified fast finality layer eigen or something, right? So it just
nice. Okay, sorry, I will not interrupt you again. That's it.
No, that makes sense. So yeah, what do? We're the builder and amplifier of Near Protocol's modular product suite. We already talked about the two products that we build. The first product is Near DA. It's already live on Near mainnet, and the other sort of product we're building is the Near fast finality layer that's currently on testnet on EigenLayer. What do those do? Well, they're targeted for scaling and expanding the Ethereum ecosystem, and alongside with basically EigenLayer security. So just to break this down a bit further, what does Near DA do? Near DA is just a stateless smart contract, essentially that exposes Near's like primitive data availability to rollups. It pretty much like it almost like an AVS that like leverages Near protocol security. That's how we want to kind of structure our sort of like a mental model. And the other thing that we're building, which sits literally on top of on Near DA, can also use other data availability solutions. I'll talk about that later. is to whenever those like sequences are available on near, an eigenlayer operator can come in and actually prove the state across L2s. So then it gives pretty much like an API that you can use. You can take that to build an application. Eventually, we'll actually put those states back to other L2s like Optimism, Arbitrum, ourselves, or a decentralized service for builders to use it. Just to give you guys a bit of a heads up, like what's been happening in the crypto space over the last year, I would say. So when we started Near went to mainnet in 2020. Eigenlayer wasn't available, so you'll have to basically bootstrap your own validator set. And a lot of folks at the time, and still some folks decide to do this, is like, I want to build all the 4 components of a blockchain in one piece. And what are those? Well, execution layer is where you take the transactions and kind of like execute them. Consensus layer is where you kind of agree on the order of transactions. Data availability is where the order of transactions live, so that other validators can come in and update the state. And the settlement layer, as you all guys know, that's where the final sort of judgment happen. And they all live together. But we see with the modular layers, and EigenDA is one of them as well. You can split those pieces into just the one component, like AWS does, or other ones. In this case, execution layer becomes Ethereum L2s. L1 becomes the settlement layer. And our view is that you can use near DA or literally any other DA. I could be EigenDA, and we can build an AVS on top that basically does this fast settlement with eigenlayer security. I won't get too much deeper into this, but how it essentially happens is that you can post transactions to sort of batches to near, and then essentially you can frame reference that on Ethereum. So you can do that with the ZK bridge. That proposer sort of like commits the data to Ethereum. Batcher pretty much publishes the data transaction ordering to near, and rollup node basically drives blocks and execute transactions. So what are the benefits? Well, consensus already provided by near to about the submission of a blob. And the other benefit is that we use a stateless smart contract, meaning we don't actually occupy the consensus with more than data it needs. So yeah, this is pretty much near DA. On the eigenlayer side, one of the things that we're super excited is that you can actually bootstrap a new on-chain, off-chain sort of service. You can do this with like any service that an L1 or L2 or any other smart contract needs. That doesn't have to be on-chain. So we believe in that world, right? Like Near already built its validator set. Sorry, just gonna come back in a second. There's somebody that I need to get in.
I think it's the door.
No worries at all.
Sorry, it's the door when you work at home.
Oh, you're good. You're good.
So what I was saying. So we believe in eigenlayer, that it brings sort of a new off-chain primitive that we can use for useful stuff like fast finality. So how do we think about this problem? Well, modularity is great. You launch a bunch of different L2s, but with that, there's a lot of problems, right? So fragmentation, as we talked before, L2s, there's new L2s launching every day. That fragments not only state, but also liquidity. With that, you get this terrible UX problem. You hear this all the time with bridges. If you go to Osmosis today on Cosmos, it's quite hard to understand like what chain you should be sending your money to. And that becomes a big problem. And the other thing, obviously, which we believe eigenlayer solves, is terrible security, right? So you have to think about different security paradigms. And we think that eigenlayer provides a sort of a one unified security on Ethereum, which is like the restaked ETH. So we believe also like near DA is not enough to solve this problem. It solves sort of the data build problem itself, but it's not sort of well versed to solve the fragmentation problem and UX problem and security problem. Traditionally, we use bridges to solve like common problems to move assets around chest chains. They could be generally fast or sometimes slow, but as we all know, as we've seen before, they're not secure enough to solve the problems we see. and we think that there's a better setup, and that we think is the Nuffle, which is NFFL. So how does that work? Well, it is a fast and secure settlement layer. It leverages both near and eigenlayer to provide an interoperability solution that verifies state attestations by by restaked ETH. This obviously allows sort of participating networks, and not only participant, but also as long as we have access to any sequence, we can dump it to near DA, or we can actually integrate EigenDA in the future, which is in our roadmap when we have enough engineers, to allowing sort of any of those to access state from the L2 side and the developer side to build a cross-chain application in a very fast way. I don't think I have to talk about this because it's the jargon that probably a lot of folks know at this point on the EigenLayer side. But what are the components, right? So you have on the Ethereum side the AVS smart contract that essentially almost like contracts directly with the EigenLayer contracts. On the Near side, you have the Near DA smart contract. Currently, we expect all the participating networks to have a DA contract. We can actually do it in ourselves too. But eventually we'll also have EigenLayer, EigenDA, and others that like come in to the market. On the rollup side, we have a SFFL verifier smart contract, and on the which basically just checks network attestations. And off-chain, you have obviously operators, which is very key component of any EigenLayer AVS that runs the AVS software to provide attestations. And we also have the aggregator role, which kind of listens all the attestations and aggregates them and gives that as a service. So how this would work, this is quite a bit of a large design scheme, but I can show you, I can break it one by one. So restakers, pretty much, as you all know, restake their capital to the EigenLayer core contract. We have this sort of the middleware contract that essentially facilitates the interaction between the off-chain nodes that we have on the AVS and the EigenLayer protocol itself on Ethereum. So restakers pretty much like delegate their restaked ETH to the operators, which then becomes obviously sort of like in a L1 sense, like validators to validate the AVS. The other thing is to mention is we almost use like Near DA here as a sort of like a hosting solution because we know that it's going to live there for a bit. What we do is for those that actually use Near as their data availability, their sequence is already available. But for those like Optimism, Arbitrum that they use it, they use Ethereum, or let's say Mega ETH that uses like EigenDA, we can look at the sequence and dump that sequence to Near because it's quite cheap and available and it finalizes quite fast. With that regards, that sort of the block relayer becomes a sidecar, right? So it doesn't have to change the implementation of the sequencer. It's not a decentralized sequencer. It's not a shared sequencer because we get this question a lot. It's just a sidecar. And once that sort of sequence is available, operators can pretty much run an indexer, like run a Near indexer, and take that sort of sequence. And finally, they basically sort of replay the L2 execution. They already have the sequence, so they compare and say, hey, this is actually the right state. And everybody sends sort of attestations, which is BLS signatures. Those are aggregator on the aggregator. And then either sort of when that's available, which finalizes in 3-4 seconds compared to Ethereum's 12-minute finality, a protocol can come in and take that and push that to another network, or we can pretty much like relay it ourselves in a centralized way to the other networks. So how would this work? Let's go through this very simple example. Let's say we're trying to consider a hello message to be sent from Fraud's network to Nadar's network, right? And then that would essentially, eventually you do something on network 2. Operators, let's say some like action on a smart contract. Operators see this change because they make a state change and they attest to the state change and make it available through API. And then if, let's say, Nadar is building a DEX, let's call Hello Protocol, takes that state and pushes that to network 1. Or in the future, because if Nadar is building, let's say, a DEX on network 1 and network 2, when that change has happened on network 1, since we're already pushing that state change to network 2, Nadar can easily take that state and kind of build an application logic there. So possible applications we see, we're actually seeing a lot more currently that when we're talking with folks. So cross-chain DEXs are pretty much a good application that you can build that is asynchronous, that will finalize in a couple of seconds. You can build a cross-chain lending platform. Let's say a new Aave kind of platform shows up, wants to do a multi-chain application. They can use this sort of primitive to build a cross-chain lending app. I gave this example before, like, for example, there's a bunch of L2s, L3s launching on the consumer side that love to do something on the other L2, which there's way more activity when they start. They could potentially do like a Lens OP kind of app that people can use. Obviously, FastBridge is a great example where, you know, they finalize in 3-4 seconds. You can build any L2 to L2 bridge that's quite useful. So, you know, this up to your creativity. We're seeing a bunch of folks that want to design like a multi-chain sort of agent platform. Let's say they want to do something. They want to modularize some of these like Uniswap interactions or others. And, you know, they can pretty much build anything that's multi-chain on the Ethereum ecosystem today. So the roadmap, we're quite excited about it. Released this 2 weeks ago, I believe. So on the NearDA side, looking at like how do we improve our ZK bridge from near to Ethereum? We're considering to use Jolt, which is a new sort of ZK VM. Stateless validation is quite interesting. So Near protocol will add increased shards. So that means we can actually increase the throughput of NearDA, which comes with way more data availability, allowing applications to build more interesting stuff. Chain signatures is quite cool. It's this solution that Near protocol is building that essentially allows a Near account to sign transactions on any network. With this, any L2 using sort of NearDA can have access to that. And the other thing that we're quite excited about, which we haven't explored yet, but thinking about it in the future, well, NearDA has, you know, Near security, but why not add, let's say, eigenlayer security there to make it more strong? As we get more and more rollups building on us, this becomes a possibility. On the NFFL side, obviously, mainnet launch is coming, so we finished pretty much the coding work, just going through some audits as we speak, hoping to launch it hopefully in August or September. And with that, obviously, we will love to build sort of like a toy example and others as we kind of hire, as a DevRel comes in, we will building, let's say, a toy application between, as I said, could be like could be between OP and Arbitrum or something to show what NFFL can do. The other thing is NFFL multi-asset. We're thinking about how do we get more assets into the NFFL system to make it stronger and maybe more dynamic. And the other thing I mentioned, which is not NFFL shouldn't actually care about what data available to use. We use NearDA because we're one of the builders, but we would essentially want to, and add in our roadmap, want to add EigenDA, Avail, or any other solutions that rollups want to use, and provide that fast finality for everyone. And finally, obviously, just like in engineering, we would love to kind of improve the NFFL as we go forward. But that's it. Like, our Twitter, my Twitter is Altan, Mr. Altan Tutar, and Nuffle Labs is our account. And if you have any questions, here's my Telegram. But yeah, should finalize.
Dang, sharing the Telegram on public. You get ready to be blown up potentially.
That's true.
No, that's great. I have a bunch of questions. That was a really nice presentation, by the way. I think that you all have a cool design style, you know.
Thank you.
But how long have you all been working on this?
So we've been yeah, not too long, I would assume.
Yeah, so we launched NearDA around, was it November? It was NearCon, right? Yeah. And that was when we started talking about NFFL. So more or less 6 months on the NFFL side, I think. And for the NearDA, it's been a while now, since last summer.
Got it. So I have a bunch of questions. We'll see how many we can get through. But in terms of like fast finality and what it looks like in practice, what would that look like in a world before you use a solution like this versus like what it would look like afterwards? Like, what is the current solution? Like, what does that actual latency look like versus what is going to be possible if a roll up or a protocol decided to start using something like Nuffle?
Yeah, so I can give an answer to that. So in a world where there is no cryptoeconomic attestation coming from an FFL, if you want to move your funds from one L2 to another L2, either you take a risk and you basically trust a bridge, right? A multi-sig bridge basically, and then you have less security. You have a huge security assumption, or you have to wait for Ethereum's finality, where you have to go to Ethereum and then deposit into another L2. And that takes however long you need to wait for that L2's, let's say, if it's an optimistic one, you have to wait 7 days. If it's a ZK one, you have to wait a couple of hours. And now the difference is that if you're transferring and then if you want to move fast, you can just use an FFL and you would get enough cryptographic security, a subset of the Ethereum validators in this case, to say that your transaction will go through and will be finalized. So that means instead of waiting for 7 days, you can just do it in 3-4 seconds. That is the world that we're trying to move towards now.
So in terms of which virtual machines or which ecosystems can interop, is there a limitation there, or is it pretty much open for anyone?
So for now, we've launched this with NearDA on the bottom, and then on top of it, EigenLayer and FFL between rollups. But in reality, as long as the EigenLayer operators are okay with attesting to any message from anywhere, you can basically pass messages. So we were thinking about even posting these and FFL headers, state roots to Near, so that Near can use it too. We can do the same thing. We can just pass along near state root to rollups so that you can pass messages between basically any chain.
Do you kind of see a specific ecosystem that you will be maybe focusing on in terms of adoption as opposed to others, though, as like a go-to-market approach? Because I've noticed that, well, there are just so many different ecosystems now. It's very, fragmented, obviously, like if you're talking about the L2 ecosystems. Or is this such like a generic product that you will essentially be marketing to everyone?
Yeah, it's a good question. Depends on the application demand side, like where people want us to provide state. I mean, providing state is easier when you have the product, right? So I would assume there's going to be like, we'll start, you look at the TVL and go down the list and say, hey, this is where the most economic activity is, and then start going down the list. But if somebody launches let's say a new L2 and we have a partnership and they want to specifically build with us, I think that we've been seeing from a bunch of folks from Eigen ecosystem and others that kind of will get prioritized, because obviously you get the first kind of being the advantage, being the cross-chain provider there, let's say.
Yeah, you mentioned decentralized exchanges, you mentioned lending platforms and bridges, a lot of like DeFi stuff. In my head, it makes a lot of sense in how you can kind of essentially do this cross-chain state update for non-financial use cases. But I'm curious, like, if you are going to start implementing all of these financial like platforms, is there a challenge in terms of like cross-chain liquidity, and how will that look for these sorts of applications? Like, what are the other things that need to be there to be taken into consideration for this to work in the real world?
Yeah, that's a good question. So what we're essentially providing, like you said, is basically state roots, right? That's what we're testing to. The application on the other side would take the state root and then do something with it. If it's a DEX, for example, it will probably provide its own liquidity. At the moment, so it could be that we also build something like this, but right now the focus is not that we're going to be building this, but we're going to be working with teams who are basically in the business of building DEXs to kind of build this out. But like you said, yes, you would require some kind of liquidity already in place.
Oops,
Oh, Nadia, we
you
cannot hear
muted.
you.
Oh, whoops, I'm sorry, I'm on mute there. Yeah, so like some of the more interesting, products that I think are going to do well are going to be these multi-chain products, just because of the fragmentation and because of all of the different things that are out there. Um, People want to abstract all that away, like the UIs, need to abstract away all these different backends. Essentially, you could think of them as. So a really good example of a product that I've liked recently is called Infinex. It's like this really high quality polished UI on top of different DeFi and other financial like products.
Mhm.
What would that look like in terms of where Nuffle would fit in for building something like that, I guess? And I guess what I'm thinking of is what would be the tech stack if you wanted to kind of abstract away a couple of DeFi protocols, or maybe build out your own DeFi protocol and implement Nuffle to kind of provide a better solution than what exists today.
So one thing that comes to my mind is, for example, right now New Protocol is working on chain signatures, releasing chain signatures, and they're trying to like abstract all of these chains and provide a chain abstracted world. What they're going to be using is their own chain signature technology, but there has to be something that provides them state roots so that they can verify that something happened on another chain. NFFL can provide the state roots for them. The same thing would go through for any of the chain abstraction stack, let's say, projects where they need some kind of an attestation, some kind of security, or some kind of a promise from underlying cryptoeconomic security that would say, yes, this happened and this is the state root, and I attest with 15 billion on the back saying like this is the truth right now, instead of multi-sigs. So that would be part of the, let's say, chain abstracted world where people don't need to care about what they're interacting with, but they would still have to make some security assumptions. And now with EigenLayer, what we can do is we can provide attestations with the cryptographic security behind it. So that would, the stack would look something like that, I think.
Okay, cool. So I want to pivot a little bit and talk a little bit more about your experience building on EigenLayer. And yeah, I'm just kind of curious, you decided to build as an AVS. What were some of the considerations that you took when you made that choice? And then I want to ask a few more specific questions about building, but let's start there.
Yeah, I can start and then I give it to Fraud. But essentially on the business side and like kind of the GTM side, I mean, this is quite exciting and primitive. Like it's never been done before. So when we saw it immediately, this makes sense because now you can do all the off-chain stuff that everybody's trying to put off, like off-chain stuff that people are trying to do. You can pretty much do them with crypto economic security. So when we saw that, we're like, oh, this makes sense, and it's been a great experience, like with working with EigenLayer folks on the labs and foundation team both, but also the builders on EigenLayer, which has been kind of inspiring us to kind of continue, asking right questions and that I'm really like excited and kind of talk every founder, every builder I talk to, it's been quite nice and very sort of entertaining and enlightening at the same time.
So if someone's like watching this and they're considering building an AVS, do you have any tips for them to be successful or anything that you've learned along the way?
Yeah, I would say try to look for ideas that you cannot really right now build on chain, and try to focus on those, because what is very, very exciting with cryptographic security or borrowed cryptographic security is that you can enable things that you couldn't do before. Like fast finance layer wouldn't be able to be possible before EigenLayer, before cryptographic security attestations, right? Focus on those. In the beginning, think about your slashing conditions. Don't think about them later on. Think about how you're going to be also rewarding the AVSs and the operators who are running it, not the AVS, restakers and operators. I think those would be very, very important when you're building on anything on EigenLayer.
Okay, awesome. We've covered a lot, so we're going to start wrapping it up here. But before I do, is there anything that you all wanted to touch on before I dive into the last questions more around developers and community and stuff?
Yeah, well, we're hiring obviously, so that's one thing to always say. So we're looking for a DevRel and two more engineers in the team. It's pretty small, fun team. Everybody's a 10x, so it's quite fun. The second thing is, obviously, if you're looking into if you have, let's say, 2 instances of the same app on any L2s, we're happy to help. We're pretty so approachable and kind of happy to help. And in the future, when it's mainnet, kind of guide you guys how to build applications on the Nuffle. That's what I would say.
Nice. Okay, so if someone wants to get involved either as a community member or as a developer, what are some of the places and things they need to be aware of?
Yeah, so Discord our Discord hasn't launched yet. It's pretty soon. It's coming. We're gonna call it Nuffle Town, so it's gonna be quite funny. But the other things are on the developer side. Go visit our docs, which is on if you go to our website nuff.tech. You can actually find everything there, and our Twitter account is pretty much, it's been purely organic, so we're kind of trying to kick that off as we speak.
Great. Well, if you want to have an additional person to follow that's very entertaining, I recommend following Alton. I actually don't follow you, Farhat, yet. I'm going to follow you right now, and so I can't recommend your feed quite yet, but I'm sure you're just as entertaining to follow. But anyway, yeah, this has been really great. I appreciate your time today, and thanks for coming on. And anyone watching, thanks for checking this out. We will have the entire recording up on YouTube within a day or two if you missed the beginning, and we will see you next week. Thanks.
Thanks for that.
Thanks a lot.